All right, so on the board, I've got 3 homework problems that were asked from my math lab. So let's go through each of these. They're just kind of a variation on the same thing that we've already done, but I understand why these ones were asked. They're all great questions. So here's the first one. We're asked to solve this inequality, x minus 3 over x plus 4 is greater than 1. So talk me through it. What's the first thing that we do when we're asked to solve any inequality? Solve the equation. Yes, we're going to solve the related equation. So I'm going to do that right here. So I've got x minus 3 over x plus 4 equals 1. Fantastic. So in order to solve a rational equation, what do I do first? Or what do I do? What do I do to deal with the fraction? I'm not going to set it equal to 0. We would do that with a quadratic equation when I have an x squared. Yeah, I want to get rid of the fraction, so I want to multiply by the common denominator. Exactly. Okay, so in this case, this is one of the examples that I only have one denominator, so identifying the common denominator is just looking at it. So by inspection, I see that my common denominator is going to be x plus 4. So far, so good? When I get to the place, if I don't answer the question that was asked, or if you have another question about this, let me know. On the left side, the x plus 4's cancel, and I have x minus 3. On the right side, 1 times anything is just that thing, so I have x plus 4. So this is the equation now that does not have a fraction. That's good news. I don't want to deal with them if I can avoid them. So now, since it's a linear equation, we've been doing this since the first day we've known each other. We're going to put all the x's on the left, the numbers on the right. And what do we notice happens when I go to put all my x's on the left? What happens to the x's on both sides? They cancel. Bonus trivia. Does anyone remember what this equation here is called? It's called a contradiction because it can never be true. There's no x value to make it true anymore. So this is a contradiction. What does a contradiction mean about this equation and thus about this equation? Empty set, no solution, right? So there's no solution to this. And the way we denote that is we use an empty set. Okay, so the first thing I did here with my rational equation, we're told to solve the equation. Where are the two things equal? Well, it turns out they're not equal. What's step 2 when I solve any inequality? Well, I've got to put my domain on the number line. So I come over here, and here's my number line. My number line represents negative infinity to positive infinity. But before I test anything, I've got to put, I don't have any point of equality, but what else do I have to notate on my number line? The vertical asymptote, because that is where the function does not exist. And so where is the denominator going to be 0? At negative 4. So I've got, here's a beautiful dotted line, negative 4. So that divides my number line, my negative infinity to infinity, into 2 intervals. I've got negative infinity up to negative 4. That's the left-hand side of the asymptote. And here's negative 4 to infinity. And now I'm going to do what I've done with the other problems. I'm going to put in a point on each side, an x value on each side, and see, is the y value bigger than 1 or is it less than 1 on each side? So over here, for negative 4, I'm going to put in negative 5 just because it seems like a reasonable value. So when I put negative 5 in, negative 5 minus 3. What's negative 5 minus 3 in the top? Negative 8. What's negative 5 plus 4 in the bottom? Negative 1. Yes, thank you very much. Negative 1. So what is negative 8 divided by negative 1? That becomes 8. Is the 8 bigger than 1 or is 8 smaller than 1? It's bigger. Fantastic. Now let's do that for the other side. Again, it doesn't matter what you pick. I'm going to go ahead and pick negative 3 or 0 or 52, whatever makes you happy. It just has to be in this interval. So when I put negative 3 in the top, negative 3 minus 3 is 6. Negative 3 plus 4 is negative 6 divided by 1. That is negative 6. So negative 6, is that bigger than 1 or is that less than 1? It's less than 1. Negative 6 is less than 1. And so now we're asked to solve the inequality. Where is x minus 3 divided by x plus 4 bigger than 1? Well, it turns out that that's bigger than 1 on the left side of the asymptote. And so the solution set is from negative infinity all the way to the asymptote, which is negative 4. Why do I have a parenthesis at the negative 4 end of this? Because it's the vertical asymptote. It's never going to be a bracket when it's the vertical asymptote. That's the reason for the dotted line, is to remind me of that fact. I think, I'm not positive, but I think in the screenshot I was sent, you were also asked to solve x minus 3 over x plus 4 less than 1. Well, the good news about the number line method is once you've done the number line, you've solved every inequality there is. So what is the solution to this less than 1? It is negative 4 to infinity. Perfect. And there we go. We're done with that problem. Okay, so that was the first one that I was sent. Any questions, comments, or concerns? I understand why that question is. There was no point of equality. So that kind of, okay, makes the world start spinning a little bit. We didn't do one that we just had the vertical asymptote. But notice my process did not change at all. Okay, I did all the same things. That's going to be true on this problem over here. This is 9x to the negative 4th minus 35x to the negative 2 minus 4 is 0. I totally understand why this question's asked. Probably, hey, Perkster, where are these negative exponents coming from? What is the deal with those? Well, if you remember, maybe not, negative exponents, a negative in your exponent is a position. It's telling you that the base is in the wrong place. So what this term really is, 9x to the negative 4th, is 9 over x to the 4th power. Can anyone tell me why I left the 9 in the numerator and only moved the x to the denominator? Perfect. The negative 4 is only with the x. There's no parentheses around this to tell me to move the whole thing to the denominator. Okay, so that's the difference there. Let me get rid of those. Okay, there we go. So then knowing that, okay, maybe that was the, oh, okay, the light bulb moment for you. How do I rewrite this term? 35x to the negative 2. 35 over x squared, then minus 4 equals 0. Now I have fractions, and that's why this problem is in this section. So now what's the common denominator so that I can clear the fractions? Remember, here's the rules for common denominator of algebraic fractions. You take one of every factor. I've only got a factor of x. And then you take the highest power if there's powers. So x to the 4th. So I'm going to multiply each of these terms by x to the 4th power. So I'm going to multiply this one by x to the 4th. I'm going to multiply x to the 4th here. I'm going to squeeze in an x to the 4th right there. And just to make sure that I'm going through the whole process, even though there's a 0, I'm going to multiply the right-hand side by x to the 4th. This is the hard step, in my opinion, of any rational equation problem, okay, is clearing the fractions. Anybody got something they want to bring up before I continue on? All right, so continuing. So x to the 4th, those cancel, and I'm left with 9. That's good, no more fraction. X to the 4th divided by x squared. These two cancel with 2 of those and leave 35x squared. And then 4x to the 4th equals 0. Now what I'm going to do here is because I like a positive in front of my highest degree term, it's personal preference. Miss Hilliard, way back in 11th grade, she's the one that drilled that into me. I'm just going to move everything over to this side so that I have a positive in front of my highest degree term. And then you have a choice. And it's the same choice you've had anytime you solve an equation like this. But there's one extra detail. I believe there was a problem or two like this when we solved quadratic equations. So hopefully this wasn't a surprise, but we'll figure it out real quick here in a minute. So I'm going to bring the 4x to the 4th over to that side, and this becomes 4x to the 4th. I'm going to bring the 35x squared over, and it becomes plus 35x squared. And then I'm going to bring the 9 over, and it becomes minus 9. So now, I'm going to do this by factoring. This indeed does factor, but if you're like, I would have never seen that factored, you are welcome to use the quadratic formula. Here's the only thing. This is the only difference. In this case, we don't have an x squared and an x. We've got an x to the 4th and an x squared. what times itself, when I go to factor here in a minute, what times itself is going to give me x squared? There you go. The spoilers, Mr. Perkins, good job. Let me pretend you did not hear that. What times itself is going to give you x to the fourth? Yeah, great job, everybody. X squared. Perfect. So if you use the quadratic formula at this point, then you're going to say, okay, x squared is equal to negative b plus or minus the square root of b squared minus 4ac. Okay, so, but I'm going to factor this. Where's my eraser? Here it is. So 4x to the fourth, again, you can factor this. I've got videos. If you don't remember your factoring from intermediate algebra, I'm totally here to support you and help you. So just send me an email and I can give you some extra direction. But the way this is going to factor is 4x to the fourth is going to be 4x squared times x squared. And then the two factors of negative 9 that are going to make my outers and inners plus 35 are going to be plus 9 minus 1. How did I know that? You can check. My outers are plus 36x squared. My inners are minus 1x squared. 36 minus 1 is 35x squared. Okay, so let me rewrite the problem right here so that everybody can see it. I was getting a little low on the board. And we're just about done with the problem. Let me get myself in the screen. So now I'm going to take each of my factors, set them equal to 0. And again, if you remember from our last unit, quadratic equations, that when I have just a simple x squared, that what I can do is I can get the x squared equal to a number and take the square root of both sides. Okay, so what I'm going to do is I'm going to add the 1 here. I'm going to divide by 4. And now I'm going to square root of both sides. So, and I get x is equal to, when I take the square root, I get a plus and a minus. The square root of 1 is 1. The square root of 4 is 2. There's my first two answers right there, plus and minus a half. Same thing here. I'm going to subtract the 9. Now I'm going to take the square root. Oh, this is a fun blast from the past. I get x is plus or minus. The square root of 9 is 3, but what do I get when I take the square root of the negative? An I. And there's my other two answers. So there's 4 answers to this. Your kind of clue to that was going to happen was in the instructions to this problem. It said find all the complex answers. Okay, yes, these are the real numbers, but they're also complex numbers. These are imaginary numbers, but they're also complex numbers. And then I'm going to save you the detail of putting in a solution set, those 4. That's a hard problem. Okay, I'm not going to lie to you and say that's super easy. It involves a bunch of things. First, it's the rational equation. Yes. Second, it's a quadratic style equation with an x to the fourth, and maybe you didn't remember that, or you only did 1 or 2, or maybe you didn't get to those problems on the last homework. So yeah, there's some extra details made that a difficult problem. So it was a really great one to ask and send to the email. All right, last problem that I was sent, and then if there's any other problems that you came prepared to ask, we have some time today, and I'm more than certainly happy to do it. So this one was to solve these two inequalities. It's the same fraction, 1 over x minus 2 squared, less than 0, greater than 0. Well, the good news about solving an inequality is it's all the same problem. Okay, so it's not doing 2 problems. We're just going to do 1, and then we'll be able to read our number line. So we already went through this. I'm not going to bore you any more than you already probably are and ask you this question. But the first thing we do is we solve the equation. So I'm going to solve 1 over x minus 2 squared equals 0. Well, the common denominator, the only denominator, is x minus 2. And then the highest power of that is squared. So I'm going to multiply here by x minus 2 squared. And I'm going to multiply here by x minus 2 squared. On the left side, everything cancels, and I'm left with 1. On the right side, 0 times anything is 0. And very similar to the previous problem that was asked, this is a contradiction. A contradiction means there's no solution to the equation. There's no place where these two things are equal, so that's empty set. Equation solved. Second thing, I'm going to do my number line. Remember, the number line represents the domain. That's also going to come into play when we come back on Monday and we solve inequalities involving square roots. Okay, remember, square roots have a limited domain, so we're going to have to think through that. So here's my negative infinity to positive infinity. I do not have a point of equality, but before I test anything, I do have one other thing I've got to note on this. My asymptotes, if there are any. What value makes this denominator 0? Say it like you mean it. 2, yes. 2. Okay. 2 minus 2 is 0. That's where my vertical asymptote is. So now I'm going to test both sides of this. So here goes. When I put 0 in, well, in the top I have 1. That's not going to change. In the bottom, 0 minus 2 is negative 2. What's negative 2 squared? 4. Is 1 over 4, is that bigger than 0 or is that less than 0? Yeah, it's just a smidge, but it's bigger. There it is. On this side, I'm going to put 3. So again, in the top, I have 1. That doesn't change. There's no variable up there. In the bottom, 3 minus 2 is 1. What's 1 squared? So 1 over 1, is that bigger than 0 or is that less than 0? I told you rational functions do not have to alternate in their graphs. This one does not. So now when I do my solution, the solution to this one, where is my fraction, according to the number line, where is the fraction less than 0? It's not. It's bigger than 0 over here. It's bigger than 0 over here. So the solution to this one is empty set. It's never less than 0. Okay, the solution to this. Where is it bigger than 0? Okay, be real careful. Okay, you said what I thought you were going to say. It looks like it's negative infinity to positive infinity, but I've got a problem. What's that problem? The asymptote. I can't just jump through the asymptote. So even though it's just that one point you have to exclude, the way you're going to notate your answer here is from negative infinity all the way to 2. And then 2 is not in the domain, so 2 can't be a solution. And then 2 to infinity. And that's the solution to that. These are real good questions. I was so glad when I got some questions in the email inbox. Thank you for sending them. I don't remember who did, but thank you. That's great. So we've got a few more minutes for any questions if you have them. Are there any other homework questions that you've brought to the table? Yeah.
I have a picture of it. There was just like a graph of only different things, and it asked the same question.
By the way, I know some of these problems said verify using the graphing calculator. We're not using a graphing calculator. It did not make any difference to your ability to do the problem. I meant to mention that. Graphing calculators are just expensive and unnecessary, so I don't have you do it. Can you walk down? Let me see your phone. Oh. Rational function. Use the graph to solution set to the problem. I don't have the graph. Oh, there it is. You do have the graph. Okay, it is horizontal asymptote of 3 and vertical 2. Okay, great. Thank you. Okay, beautiful. I will need a little more detail from you, Clarissa, so keep that open. I got the big points here. So 1, 2, 3, we've got a horizontal asymptote. The vertical was here. Was it above or below the asymptote on this side? It was above. So it looked something like this. Okay. And then here, where did it go through the x-axis? What point? -1. And where does it go through here? Oh, it doesn't, because that's a vertical asymptote. Trick question. Okay, so, okay, beautiful. Now, what inequalities are we solving using this graph?
It says the function of x equals 0 and the function of x is less than 0 and then greater than 0.
Perfect. Great. So this is something we've done every time. I probably should have put one of these, so I've got to adjust my notes. I probably should have put a graph on there, but that's okay. We can do this right now. So we have to interpret this graph and see where is Where is this equal to 0? Where is it bigger? Where is it less? Fantastic. I love this problem. Okay, there'll be a problem like this on the test. So I'm glad Clarissa came prepared to ask this. So first, where is the function? Well, I'm going to ask you the same thing I've asked you many, many times when we've dealt with functions. When you see f of x means what value? The y value. So this is asking, where is the y value 0? And the y value is equal to 0 at one place. Where is the y value 0? Right here, -1. That was the point that I asked for because I knew that was going to be one of the things we had to do. This is the y value 0, and it happens at the x value -1. So that's my solution set right there, -1.
That's where I got it wrong. I don't know why it didn't like -1, 0. Like I would put -1 because I would see it goes to -1, but I would mark it as wrong.
Did it ask for a, I guess, did it ask for a point or did it ask for a solution set? Okay, so I don't know. Then I don't know why it's asking you. It should just be the squigglies with -1, so that they've got a typo in the system. Okay, so when I put this on the test, this is how you notate the answer. Now, where is it less than 0? Well, just point out to me, okay, there are several parts on here. There's this part where it's above that -1. There's this part right here, and then there's up here. So we're going to call that 1, 2, and 3. 1, 2, or 3, or any combination. Where is that less than 0? Where are the y values below 0? 2, right here. Here's where it's equal to 0. We just identified that. So this right here is the y values that are less than 0, below the x-axis. So where does that start happening? What x values, what's the lower boundary that starts happening? -1. What's the upper bound? What's the x value where that stops happening? Goes all the way to the vertical asymptote, which is 0. So remember, this isn't a point because we have an inequality. This is a solution set. It's an interval. And what am I going to put at the -1 side where the point is? I'm going to put what? Why a parenthesis? Why not a bracket? There's no equal sign. Beautiful, well said. And at the 0, what am I going to put at the 0 side? Why a parenthesis there? Yes, well said. Vertical asymptote for everybody watching at home. Okay, so excellent. Well done. All right, now, where is this bigger than 0? Okay, so again, 1, 2, 3, 1, 2, 3. Where is it above the x-axis? Okay, 1 right here and 3 right here. All of this, all those y values are above the x-axis. And on the test, I label this, right? These are the y values 1, 2, 3. You can clearly see, no tricks or gimmicks. Those are the y values that are bigger than 0. So where does that start happening for this interval? -∞. And where does that stop happening? -1, because that's where it's equal, and then it goes under. So then we got a union because we got another interval. Where does it start again being bigger than 0? The vertical asymptote. And where does it stop happening? There you go. Excellent.
So for the one that's divided is less than 0, you put another 1 to 0 because it's the asymptote is at the vertical asymptote is at 0.
Exactly. Yes. The vertical asymptote is right here. And so this, where I'm coloring over with the red marker, those are the y values that are less than 0. So that starts happening at -1, which is the equality point. That's why we got that there. And then these x values, they get progressively closer to 0, but they will never hit it.
So that's why it's not a thing.
Exactly. Yes, because we're not talking about the y values. We're always giving, this goes back to when we first started doing this. We're always giving the x values that produce these y values that are less than 0. Great. Well said. Okay, great questions, everybody. I appreciate it. If you have others, then send them to me or come by my office. I'm going to stop this recording